So today we're going to talk about components of vectors. Basically, vectors, usually the ones that we're working with in this unit, are going to be done in an orthogonal way, i.e. they're going to be perpendicular to each other. Essentially what we're end up going to do is we're going to end up creating a right triangle, at which point we can use either cosine or sine to find angles or sides. So, a member of the Brazilian soccer team kicks a ball with a force of 150 newtons at an angle of 40 meters to the ground. So here's what we're going to do. We're going to go and create that angle and that thing. So this is our 150 newtons, right? We said that its angle that it hits the ground with is going to be 40 degrees. Now, we need to figure out what magnitude that the ball moves forward. And there are two forces that act on the ball as it moves. There's a force that's pushing the ball sideways along here. And then there's a force that's pushing it up as it's going up into the sky. I'm going to call this y and this one x. So the x direction force and the y direction force. For A, in order to calculate the x direction force, you got to notice that this forms a right triangle. Remember, there are two orthogonal forces. One that pushes up for the ball to go upward, and then one that moves it downward. Now, in order to figure out the force that kicks the ball horizontally, all we're going to do is figure out what the cosine of 40 is to find this value x. So let's go and do that right now. That we get the following equation. Cosine 40 is x bar over 50. And what we're going to do is we calculate it, doing our normal thing. We solve for x. In this case, we have 150 cosine of 40, which gives us, when we do our calculation, 114.9 newtons. Now it's 114 newtons. Now I'm actually going to say this is down, and this is up, and then this is right and left. You'll notice that a lot of the times I tend to give myself some form of directional marker that allows me to calculate and say which way this is moving. So this is 114 newtons, and we're going to eventually say that it's moving to the right 114 newtons. And that basically tells us what our vector is. Now, let's do the same for the force that raises the ball. The force that raises the ball is going to be the sine of this. The sine of theta is going to be this over this part. So now when we do our calculation, we're going to get b. So b is equal to sine of 40 is equal to y over 150. Do your calculations. We end up with y is equal to 150 sine 40. And in this case, y is 96.4 newtons, and we're going to give it a direction. Its direction is up. Simple calculation. Basically, we can come up with a vertical and a horizontal component for every vector, every resultant vector. We call these vectors perpendicular components because they don't freely act upon each other. It's just their result that we care about. Basically, we always just have to create a right angle triangle to find the up and down vectors, or the left and right vectors, or whatever component directions you use. So I will always tend to put something like this on my sheet. For this next problem, we have a person that pulls a sleigh with a force of 200 newtons along a rope that's at an angle of 35 degrees. So imagine this. I'm going to go and draw my little, so this is down, up, right, left. And imagine I have a box and the box is being pulled, and the angle at which it forms with the ground is 35 degrees. So what we're looking for is this blue arrow here that pulls it this way, and then this red arrow here pulls it up. So you notice we've made another right triangle just like before. So I'm going to call this X, and then I'm going to call this one Y. So for A, it says find the force that moves the slave forward. So let's change this. Change these units that we have here for left and right to forward and back. So here's what we're going to do. Let's do our calculation. For A, we're going to write cosine of 35 is going to be the vector, not h, we're going to call this x, representing the horizontal motion, divided by, well, we said that our force was 200 newtons. And then we simply divide by 200. In order to find x, we rearrange and we get 200 cosine of 35. And we get our value of x being 163.8 newtons, and we can say that is moving forward. So now for B, let's find the force that's lifting the sleigh. Force that's lifting the sleigh is calculated by sine of 35 equals y over 200. We do our calculation. Y is equal to 200 sine 35, which equals y is equal to 114.7 newtons. And I'm going to say that this is 417 newtons up, and that is our component for y. Now, what would happen if we had a shorter rope? If we had a shorter rope, then what would happen is we'd end up having literally a higher angle in order to create these two different forces. We would have a bigger angle, so something greater than 35, maybe 55 or 45 degrees would create the appropriate vectors. That's what would happen there. Now we're going to determine the perpendicular components of a train traveling at north 57 degrees east. In order to do this, this is a weird type of calculation. We have to basically draw a directional finder. So this is north, this is east, this is south and west. So I always start by saying, using the acronym, never eat sour watermelons. Some people say never eat shredded wheat. Remember, I'm Jamaican, I'm always thinking of fruits. Okay, in order to do this final calculation, what we have to do is you have your directional finder, and what you do is you use your directional finder to always set up another directional finder on your page. And then it says it's north 57, so it starts north and sweeps to the right 57 degrees to the east. So here's what we do. We go and draw our vector. I'll draw it in red. So here's my vector, and here are the two components. Basically, if you think about it, there's a force that's pulling it up this way, and then there's another force that's pulling it to the east that way. And the angle in between them, in between the up and down, the north and south, is 57 degrees. So that says we start north 57 and we sweep to the right 57 degrees to the east. So that helps us form our triangle. So let's go and calculate my y vector and my x vector. Let's go and compute the x vector. So the x vector, if I look at this, here is the angle, here is the opposite side. So I would say that I would be using sine for that. So I would have sine of 57 degrees is equal to, well, x over, well, this is supposed to be 200 kilometers an hour. In order to calculate that, I just put that in there and I solve for x. X is equal to 200 sine 57 degrees. We do our calculation. X in this case is 167.7 kilometers an hour. Now let's give it a direction. In this case, it's moving to the east. So that's A. B. Let's do this again. For y, we'll go sine. Nope, not sine. We'll use cosine because the angle is directly beside the adjacent side. So we've got cosine of 57 is equal to y over 200. Do our calculations. We get y is equal to 200 cosine of 57 degrees, which gives us y equals 108.9 kilometers per hour. And since this is a vector, we must tell us which way it's going. In this case, it's moving north. And we're done.